You're listening to the N2K Space Network.
Hey everybody, Dave here. Have you ever wondered where your personal information is lurking online? Like many of you, I was concerned about my data being sold by data brokers. So I decided to try Delete Me. I have to say, Delete Me is a game changer. Within days of signing up, they started removing my personal information from hundreds of data brokers. I finally have peace of mind knowing my data privacy is protected. Delete Me's team does all the work for you with detailed reports, so you know exactly what's been done. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for our listeners. Today, get 20% off your Delete Me plan when you go to joindeleteme.com/N2K and use promo code N2K at checkout. The only way to get 20% off is to go to joindeleteme.com/N2K and enter code N2K at checkout. That's joindeleteme.com/N2K, code N2K.
Today is February 11th, 2025. I'm Maria Varmazis, and this is T-Minus.
T-minus 20 seconds to LOS T-Drift. Go for deploy. Roger, roll.
The Texas Space Commission has awarded over $47 million in grants to space companies operating in the state.
4.
Germany has committed an additional 870,000 euros to support the development of an offshore launch platform that will operate from the North Sea.
3.
China launches its first Long March 8A carrying communication satellites for the Guowang constellation.
2.
DARPA selects 2 universities to demonstrate novel technology for building future large structures in space.
1.
NASA selects SpaceX to provide the launch service for the Pandora mission, which will study at least 20 known exoplanets and their host stars. And it is International Day for Women and Girls in Science. We'll have more on that later in the show. And we're highlighting Madison Feehan in today's chat. Now, Madison is the founder and CEO of Space Copy, looking at in situ 3D printing in space using available materials. It is a really fascinating concept, so stick around to find out more. Welcome to this Tuesday's Intel Briefing. Let's get into it. NASA has selected SpaceX to provide the launch service for the Pandora mission. The selection is part of NASA's VADR, or Venture Class Acquisition of Dedicated and Rideshare Launch Services contract. The contract allows the agency to make fixed-price, indefinite delivery, indefinite quantity awards using VADR's 5-year ordering period, with a maximum total value of $300 million across all contracts. Pandora is a joint effort between NASA's Goddard Space Flight Center and Lawrence Livermore National Laboratory in California. The mission aims to study at least 20 known exoplanets and their host stars to find out how changes in stars affect our observations of exoplanet atmospheres. During its 1-year primary mission, Pandora will observe each exoplanet 10 times, observing for 24 hours each visit. It'll capture critical data about the planet and its host star during transits, which is the event where a planet crosses in front of the star that it orbits. The satellite will use a 17-inch wide all-aluminum telescope to simultaneously measure the visible and near-infrared brightness of the host star and obtain near-infrared spectra of the transiting planet. This combined data will enable the science team to determine the properties of stellar surfaces and cleanly separate star and planetary signals. Pandora is due to launch later this year. DARPA has selected 2 universities to demonstrate novel technology for building future large structures in space. DARPA, or the Defense Advanced Research Projects Agency, is a U.S. government agency that develops new technologies for the military. And the selection is part of the third and final phase of its NOMAD program. And the program plans to conduct a pair of small-scale orbital demonstrations to evaluate novel materials and assembly processes in space. DARPA says that Caltech and the University of Illinois Urbana-Champaign demonstrated tremendous advances in the first two phases and have now partnered in Phase 3 with space launch companies to conduct in-space testing of their novel assembly processes and materials. Very cool. Caltech is focused on mass-efficient designs for in-space manufacturing and has teamed with Momentus to demonstrate its technology aboard the Momentus Vigoride orbital services vehicle, which will launch on the SpaceX Falcon 9 Transporter 16 mission scheduled for February 2026. The University of Illinois Urbana-Champaign is focused on in-space materials and manufacturing and has developed a high-precision in-space composite forming process. And they have partnered with Voyager Space, aiming for launch to the International Space Station aboard NASA's commercial resupply mission NG-24, which is currently scheduled for April 2026. Moving over to China now, and China has launched its long-anticipated maiden flight of the Long March 8A rocket. The spacecraft lifted off from Wenchang Satellite Launch Center, carrying a group of satellites into orbit for the national Guowang mega constellation. The China Academy of Launch Vehicle Technology developed the Long March 8A, sharing that the vehicle is a modified version of the Long March 8. Makes sense. The company says it boasts an increased payload capacity and enhanced mission adaptability, and will provide crucial support for large-scale satellite constellation deployment. No details are immediately available about the amount of satellites that it transported in today's launch. Let's head on over to Europe now, and Germany has committed an additional 870,000 euros to support the development of an offshore launch platform that will operate from the North Sea. The North Sea launch platform is being developed by the German Offshore Spaceport Alliance known as GOSA. And GOSA is a joint venture by Tractebel DOC Offshore, Media Mobile, OHB, and Harren Shipping Services. The German government committed an additional 2 million euros to the project, and the proposed platform will be constructed on the 170-meter-long Combi Dock 1 vessel and will accommodate launchers with a mass of between 36 and 52 tons. A 2020 feasibility study stated that the development and operation of the North Sea launch platform would cost between 22 and 30 million euros over 6 years. And let's head down back to Texas now, y'all. The Texas Space Commission has committed $47.7 million in grants to 5 space companies operating in the U.S. state. The grants are part of Texas's Space Exploration and Aeronautics Research Fund, known as SURF. The Commission's board of directors voted to award grants ranging from $7 to $5 million to Blue Origin, Firefly Aerospace, Intuitive Machines, Space Exploration Technologies, aka SpaceX, and Starlab Space. The board says that the grants will support Texas companies as they grow commercial, military, and civil aerospace activity across the state. And that concludes today's Intel Briefing. Our producer, Alice Carruth, has more on the stories that didn't make it into the top 5 today.
Indeed I do, Maria. There are 2 additional stories we think you should be aware of today. Norway has contracted Thales Alenia Space for the Thor 8 telecom satellite, and space journalist Michael Sheets has announced his departure from CNBC. We wish him the best of luck with his new move, and we're eager to find out where that is. We will, of course, share those details with you when we find out.
And Alice, where can we find those stories?
Links to all the stories mentioned throughout the show are in the selected reading section of our show notes and can also be found at space.n2k.com. Just click on the episode title.
Hey, T-Minus crew, if you are just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. Also, please do us a favor, share the intel with your friends and coworkers. Here's a little challenge for you. By Friday, please show 3 friends or coworkers this podcast. A growing audience is the most important thing for us, and we would love your help as part of the T-Minus crew. If you find T-Minus useful, please share the show so other professionals like you can find us. Thank you. It means a lot to me and all of us working here on T-Minus.
Cyber threats are evolving every second, and staying ahead is more than just a challenge, it's a necessity. That's why we're thrilled to partner with ThreatLocker, the cybersecurity solution trusted by businesses worldwide. ThreatLocker is a full suite of solutions designed to give you total control, stopping unauthorized applications, securing sensitive data, and ensuring your organization runs smoothly and securely. Visit threatlocker.com today to see how a default deny approach can keep your company safe and compliant.
Our guest today is Space Copy's founder and CEO, Madison Feehan. And I caught up with Madison at SpaceCom in Florida to find out more about her company.
We are a woman-owned small business based in the United States and Canada, and we are an in-situ logistics and additive manufacturing company, and we are focused on building 3D printing technology to power the next generation of spaceflight. So,
not a small challenge to take on.
It is not. It is super complex, but we operate both in space and terrestrial ecosystems. And something that is a little bit unique about us is that all of the feedstock that we're generating for use is completely derived in situ.
In situ, as in, so we're on the moon, and that feedstock is coming from regolith, right?
Absolutely. If you're on the surface of the moon, we're talking regolith. If you're in an extreme or austere environment here on Earth, we're talking about soil, sand, basalts, recycled metal, you name it. We can break it down and print infrastructure of various different sizes and capacities.
Okay, mind blown. I'm just going, wow, the challenges of doing that, impurities, I can't even... Additive manufacturing to me already on its own seems like magic. I know it's science, but but when you're talking about just taking what's around you and using that as raw material, that gets into, I didn't know if that would ever be possible. It's amazing to know that you are developing that. That is quite incredible. Please tell me more about, this mission, what you're making. That's just amazing.
Well, it is certainly a really difficult technology process to wrap your head around, but it is an incredible one nonetheless. So how I like to break this down is into 4 different stages.
Sure.
The 3D printing technology starts first with stage 1, what we call beneficiation, or maybe the less technical term is mixing. So we take whatever raw material that you have on site to work with, and we break it down through a jaw crushing, dual centrifuge mix, a nice mechanical sieve, and a vibrational separation process. And that will take your biggest rocks and chunks and break it down into a fine powder-like material. Once we've been able to achieve that nice fine particle size distribution, then we carry forward into Raman spectral scanning,
right,
just basically taking a big old laser beam and scanning the chemical composition of that feedstock.
That's cool.
Then stage 3, the fun stuff, the actual 3D printing. We have 2 different systems, by the way. We have a laser-based system for really complex parts like precision tools, and we have an extrusion-based system for the larger scale infrastructure like bricks and heat shields and launch pads. And then last but not least, stage 4 is AI and autonomy. So everything that I just explained, it's 100% autonomous.
I would imagine, given the locations that we're talking about using this at, it would need to be.
100%, 100%. We've got a little 5-axis robotic arm that's located inside that 3D printing chamber. It's actually going to lift those 3D printed parts off of that build plate and drop them into a collection bin so it's easy for astronauts to access them.
How do you anticipate this being used? I know it's evident, but just walk me through it anyway.
Well, we've kind of got a little bit of a milestone timelines schedule in place. So first and foremost is the Earth-based applications. Well, we can immediately use this technology in natural disaster areas and combat zones and places where it's just straight up logistically challenging to get infrastructure shipped into certain locations. So we estimate being able to deploy this tech into ecosystems like the Arctic or desert or even underwater as early as 2026, which is right around the corner. And then as for the lunar missions, we've got some fantastic partners that are helping us to make this happen with the lofty goal of being able to land one of our 3D printers on the surface of the moon by 2031. And we are super excited to be having a cislunar flight test that is being planned for as early as the end of this year. So we're going to send up the world's most basic 3D printer halfway to the moon and back and see if we can't print with some regolith simulant. And you know what? If successful, we would be the first folks to ever do so.
Wow. I love when I get have these kind of conversations where it's like, this is the sci-fi future that I know I dreamed of, and someone is working on that. Tell me a little bit about sort of like your long-term vision for what you're working on. I mean, you've already sort of outlined quite a bit of it, but I mean, Mars, maybe? I mean,
Oh yeah. You know, the space dreamer in us is always looking for, let's land on Mars, let's get this concept going. You know what? As a matter of fact, I've been pioneering this concept since 2017. The business has been around for a couple of years now, but the idea has been formulating for much, much longer. And when I first came up with the concept, it was specifically around 3D printing for Mars.
Wow.
That's on the peripheral. It's the long-term goal. And you know what? If we're looking at the way that space travel is shaping up, and we're talking about being interplanetary species, sending humans to space in long-term duration missions, think of this in the greater context of the mission planning requirements. Because right now, launch costs from Earth to the surface of the moon, if you're talking per kilo, you're ranging from around 800,000 to 1.2 million US dollars. It takes almost 22,000 kilograms to keep 4 astronauts alive for a year. You're talking over $6 billion easily in just infrastructure being shipped up. And that's not even considering what the cost would be to send it even further to places like Mars. So immediately you're seeing the need for the technology, and you're seeing that not only is it possible, but it's needed. So when I look at the kind of long-term vision 5 years from now, even 20 years from now, the goal is kind of a bit of a technical balance with a humanitarian balance. So not only being able to do some cool science, because you know that's what we're all here for, but also having the benefit of changing the way that humanity looks at infrastructure development, that we look at sustainability, and that we look towards the future of science as being proactive.
This is really capturing my imagination, and my eyes is going. I'm just so curious, like who you're working with and what kind of projects. I mean, so you mentioned really underwater. Sorry, I'm a little bit like, wow, this.
I know, right? There's so many different ecosystems that Space Copy's technology can operate in. So let me run it down really quick. So those terrestrial applications, we're talking Arctic desert underwater. And I say underwater because it's got that microgravity environment, right? So it's a really fantastic, what we refer to as like the lunar proving test ground, right? Same thing goes with Arctic, right? We're talking about extreme thermal gradients of space. Why not try to do that here on Earth first, and not only to validate the concept, but also to actually benefit the people working in those ecosystems already?
Right.
And then, as far as space goes, we're talking about microgravity, we're talking about cislunar, we're talking about lunar, we're talking about the deep space all the way to Mars. And then as far as actual timelines go, I was mentioning that cislunar test flight that we're planning.
Yes.
And then actually we have a Arctic field test planned for 2026. For those of you who may or may not be familiar with the Mars Analog Test Site, the Houghton Impact Crater way up in the northern Canadian Arctic Circle. We've got some partners up there that are helping us to actually get a basic printer up there, get a prototype going, get some stuff printing, and the best part is that not only is it a terrestrial feedstock, but it's also the site of an asteroid impact, so you get some of that space-based material too.
That is so. You've got to love your job, what you're building. I can just tell you're really jazzed talking about this. And this is a really cool thing.
I do love my job. I will talk to whoever will listen about this technology, not only because I'm so proud of what we're creating, and the incredible team also behind the story that has helped to create this and pioneer this, but also because of the proud partners that we've had, from academic institutes to government organizations like NASA. We've got such a huge repertoire of folks that have come through for us, that are not only fascinated in our technology, but are looking for ways to support it. And at the end of the day, that's one of the things I really love about the space community.
Yes.
Is that, it's so dynamic, but also so supportive.
We'll be right back.
And now, a message from our sponsor, Zscaler, the leader in cloud security. Enterprises have spent billions of dollars on firewalls and VPNs, yet breaches continue to rise by an 18% year-over-year increase in ransomware attacks and a $75 million record payout in 2024. These traditional security tools expand your attack surface with public-facing IPs that are exploited by bad actors more easily than ever with AI tools. It's time to rethink your security. Zscaler Zero Trust plus AI stops attackers by hiding your attack surface, making apps and IPs invisible, eliminating lateral movement, connecting users only to specific apps, not the entire network, continuously verifying every request based on identity and context, simplifying security management with AI-powered automation, and detecting threats using AI to analyze over 500 billion daily transactions. Hackers can't attack what they can't see. Protect your organization with Zscaler Zero Trust and AI. Learn more at zscaler.com/security.
Welcome back. Today, February 11th, is the International Day of Women and Girls in Science. This one's personal. I grew up in a house where science and engineering were revered and encouraged at every turn. My peer group in high school were other science-minded girls like me. There's a photo in my high school yearbook of our computer club that always makes me chuckle because there I am off to the side, the only girl. It's a dynamic that you get used to. Even at engineering school and college, not unlike high school, it wasn't unusual to be the only young woman in a lab or maybe one of a handful in a large seminar. It was easy for us to remember each other. Us engineering school women would often become friends, toiling away at problem sets in study rooms for hours every day, sharing notes, helping each other prep for exams, rotating who would go to office hours. And it's funny, outside of engineering, many of us probably wouldn't have been friends. We really didn't have all that much in common interest-wise, but we knew what we were all up against, so we banded together for survival. I'll skip to the chase. We were the class of 2005, so it's been 20 years. Many of the women I knew from those days went into their chosen fields after graduating. But now, these decades on, of the dozens of women that I knew starting their careers in science and engineering, maybe 4 are still working in them. Now, career changes happen for all sorts of reasons, like in my case, where it simply is just not the right field for you. It happens. But sometimes it's the result of a slow fade, where over the years you have to keep fighting an invisible war, and sometimes you just simply get tired of it. Whatever you want to call it, a retention problem, a cultural problem, it goes way beyond any federal mandate or national border. And there are conversations happening, said and unsaid, especially right now, about whose stories are celebrated, whose competence and credibility is celebrated, who rises in the ranks with like-minded peers, whose accomplishments are worth a damn, who is a merited hire. In other words, in science and engineering, who belongs? Well, women do. This is only the 10th anniversary of International Girls and Women in Science Day. So all you trailblazers toiling long hours over problem sets, labs, trials, reams and reams of data, connecting with that spark of joy that ignited that love of science, ladies, I see you. Our world needs your perspective and your expertise more than ever. Keep fighting, out of spite for the haters if nothing else. And please remember, even if you are the only one in the room, you belong. That's it for T-Minus for February 11th, 2025, brought to you by N2K Cyberwire. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T-Minus are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K's senior producer is Alice Carruth. Our producer is Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben. Peter Kilpie is our publisher, and I am your host, Maria Varmazes. Thanks for listening. We'll see you tomorrow.